Hello everyone, I'm Sayar Robin. Welcome to Sayar Robin's channel. Today I'm going to show you how to approach absolute value problems, which is from the past, not past papers, a specimen paper, Cambridge IGCSE Additional Mathematics 2020, number 5. Okay, let's get started. Right. So in this problem, you see that on the axis below, sketch the graph of y is equal to modulus of 2x plus 5. Okay, so this is one function, and the graph of y is equal to 2 minus x, modulus of 2 minus x. This is another function. There is two functions here, stating the coordinates of the points where each graph meets the coordinate as x. So which means we're going to find the x-intercept and the y-intercept too. That's why before we get into this topic directly, we have to know about some properties of the absolute value functions. Okay, so I'm going to show you the what is the main properties of the absolute value functions in this problem. Well, here we go. Okay, this is Desmos. You can find in the internet. Well, for example, y is equal to modulus of x. Okay, this is a simple functions, and then y is equal to 3x 2x and then plus 3 modulus of 2x plus 3. What do you see? What do you notice? Okay, you see that here we go. So all of the functions have no graph line below x-axis. Okay, and then all of the absolute value functions are symmetric at the point which is meet on the x-axis. Okay, here we go. This is negative 1.5, this is 0, 0, right? Okay, therefore, so we have to notice that, so all of the absolute value functions are really symmetric. That's why, so we are going to apply this fact on these problems that we are now going to carry out. Here we go. Okay, y is equal to, so I'm going to use these peaks because if we are going to draw the graph, so we don't use these peaks, right? Y is equal to modulus of 2x plus 5. Okay, first of all, we're going to find the x-intercept. That's why y must be 0. Y is equal to 0 implies, so in order to get 0, 2x plus 5 must be 0. X is going to be negative 5 over 2, therefore negative 2.5. Okay, this is x-intercept. How about y-intercept? Obviously, we are gonna set 0 into x, right? X is equal to 0 implies y is going to be, one is substitute 0 into x, that's going to be 5. Modulus of 5 is going to be 5. Okay, 0 comma 5 and negative 2.5 comma 0. Okay, then we are going to find next intercepts for the another function. Y is equal to 2 minus x, and then y is equal to 0 implies, so 2 minus x must be 0, x is equal to 2, right? And then x is equal to 0 implies, x is equal to 0 implies y must be, okay, we're going to substitute x is equal to 0 into this place, right? So what's going to be, and then 2 modulus of 2 is equal to 2. Okay, so let's plot it. Let's locate the points now. Why? Okay, so I'm going to use this color again. So we better use it green color. Okay, and then negative 2.5 comma 0. So we're going to make some tick for this line, and then this is negative 2, this is negative 4, let's say this is negative 6, and then this is negative 8, and then 2, 4, 6, 8, and 10. Okay, negative 2.5. Negative 2.5 is going to be here. Okay, comma 0 is this point, and then 0 comma 5 is going to be, okay, this is probably on this axis, right? So but then we're gonna make it 2 and then 4 and then 6 and then 8 and then 10 and then 12. Okay, you can take the any scale you like on y-axis because there is no restrictions on a y-axis. Okay, therefore x is equal to 0, y is equal to 5 must be in this point. Okay, when you connect these 2 points, there's going to be like this. Okay, and then so you have to draw by using a ruler, and then this is symmetric. Symmetric means negative 2.5. Okay, and then this one also negative 2.5. Okay, double is this point, and then so must be this point must pass through negative 6 comma 5. Right, therefore we are going to connect like this. Okay, this is for the first function y is equal to 2x plus 5. How about another function? So we already found the points which have to be located on axis 6 and y axis 2. X is equal to 2, y 0. Okay, it must be this point. And then x is equal to 0, y is equal to 2, must be this point. Okay, we are going to connect these 2 points. So I'm going to use a blue color for this one. Okay, and then so all of the absolute value functions are, as you ever know, symmetric. Therefore, here we go. This distance is 2, and then this distance must be also 2, and then 4 must be the one coordinate of 4 must be also 2. Therefore, we are gonna draw like this. Okay, by using a ruler, so you might draw precisely and accurately, right? So we're gonna delete this part. We don't need it, right? Okay. Generally, your figure is going to be like this, but that's not really exact. And then if you want to see the exact value, so I'm going to show you like this. Okay. So we are going to correct the function 2x plus 5, right? And then next thing is y is equal to, and then 2 minus modulus of y is equal to modulus of 2 minus x, right? Okay, then okay, so your actual graph is going to be like this, right? All right, then we are going to continue for the problem number B. Here we go. So problem number B is modulus of 2x plus 5 less than or equal modulus of 2 minus x. In first problems, the problem want you to state the coordinates, right? So I've just forgot about it, sorry. Stating the coordinates of the point. So we just need to state the coordinates of the point where each graphs meet the coordinate axis, which means x-intercept and y-intercepts 2. Okay, this point is 2 comma 0. How about this point? 0 comma 2. How about this point? And then 0 comma 5, and then this point is negative 2.5 comma 0. This point have to be right. And then we're going to continue for the next problems, which is 3 marks. So we're not going to think about these 2 things, right? These inequalities. So you may use your graph which have been drawn in problem number 5a, but then so this graph is not working properly for the time being because this is not drawn to scale, and then so I'm going to show you by using algebraic method, right? If you're going to solve these 2 absolute value functions, first of all you have to suppose those 2 inequalities are the same. Therefore, I'm going to use let 2x plus 5 is equal to modulus of 2 minus x. After that, how are you going to solve this equation? There are 2 methods, 2 ways. And then if you're going to take 2x plus 5, if you're going to remove, and then so you have to put plus or minus before 2 minus x. Okay, and then if you continue, you have some value, right? 2x plus 5 is equal to, if you're going to use positive sign, so 2 minus x, or 2x plus 5 is equal to negative 2 minus x, right? So I'm going to move a bit to the left. And then so we can continue, so 2x minus x, it became positive x, they're going to be 3x is equal to negative 3. X is equal to negative 1. All right? And then 2x plus 5 is equal to negative 2 positive x. And then it's going to be x is equal to negative 7. This is one way in order to get the value of x, or the point of intersection of two given functions. Okay, I'm going to show you another method, which is no other than squaring both sides, right? Okay. Squaring both sides means 2x plus 5 the whole square is the same as 2 minus x the whole square. It's going to be 4a squared plus 20x plus 25, right? So I want to expand this thing, so it's going to be 4 minus twice of the product, or 2 times is going to be 4x plus x squared. Okay, and then so that's going to be 3a squared. So we're going to make right hand side is 0. And then negative 4 is going to be positive 4x, is going to be 24x. And then this is going to be positive 21. After that, we can divide throughout by 3. Therefore, a squared plus 8x plus 7 is equal to 0. By cross multiplication or using calculator, so you can easily find out the value of x. X plus 1 times x plus 7 is equal to 0. So x is equal to negative 1 or x is equal to negative 7. Now you have the answers, correct answers. Okay, you guys, any method you like. Okay. After that, so we are gonna think about that x, these two function is less than or equal. Not equal. Not equal is, you know, so we just need to take, we just need to find the value of n of x, or the point of intersection. That's why we equate them as a temporary. In fact, we must find the less than or equal to minus x. All right. Therefore, in two graphs, one graph is less than or equal another graph. Okay, here we go. The red color is, you know, the first function, and the blue color is the second function. If you're going to find the less than, so let's say x minus 1. Here we go. Okay, minus 1. I'm going to show you. Here we go. Minus 1. X is equal to minus 1. This is point of intersection. And then next one is negative 7. X is equal to negative 7. Negative 7 is going to be here, right? So if we are going to draw with the scale, so that's going to be like this, probably like this, right? So I'm going to erase these things. Okay. Okay. Okay, let's say like this. Okay. So we know the point of intersection of these two graphs, and then we're going to find red color graph is less than or equal blue color graph, right? Therefore, our answer must be negative 1, and x value must be negative 1 and between negative 7 and negative 1. Okay, x must be between negative 7 and negative 1. So we must put the equal sign. Okay, red color is below the graph of blue color, in between negative 7 and negative 1 only. Okay, outside of the negative 7 and negative 1, red color is always above the blue color line. Here we go, obviously, right? This is our final answer for number 5B. Okay, everyone, I hope you enjoy it. So see you again for next problems. Have a wonderful time.